In this video, I'm going to be talking about the form y equals m lots of x minus b. Now this is another way of writing line equations. Not as popular as y equals mx plus c, but in some ways more useful. So it is a good idea to be familiar with both forms, and in fact, lots of forms. So here we've got three of exactly the same equation. And so I made this clear in my last video, these are all the exact same equation, because to get from the first one to the second one, we take away 2x from both sides. And to get from the second one to the third one, we factorise. So although these three are all the same equation, this second one here is in the form y equals mx plus c. Now that's useful because negative 2 is m, it's the gradient, and 4 here is the y-intercept. But this bottom equation, this one is in the form y equals m lots of x minus b, because that negative 2 is the m, and that 2 there is the b. So this is y equals negative 2 lots of x minus 2. That is in the form y equals m lots of x minus b. Now on the screen you will see a number of different equations that are all in the form y equals m lots of x minus b. So some surprising ones might be the second one here, because b is 0 in this case, but that is still technically in the right form. At the bottom one here we've got 5 lots of x plus 2. That is still in the correct form, it's just that b is negative 2, because we would have x take away negative 2 would be the same as x plus 2. And of course we can have weird numbers as usual, so we can have surds or we could have fractions as our values for m and b, and that wouldn't concern us. Now on the other side of the screen we're going to see some things that are not in the correct form. So this first one here is in the form y equals mx plus c, which is absolutely fine, it's just not what we're talking about in this video. The second one here has got a 2 in front of the y, so we can't have that. This third one has got a root x instead of just an x, can't have that. The fourth one has got x squared, can't have that. Going back to the top, this one here is again, it's sort of in the right form, although not quite. We would have to play with it just a little bit to make it right. We would have to take out negative 1 as a factor and rewrite this as negative 5 lots of x minus 5. So nearly in the correct form, wouldn't take long to get it in the right one, but it's not at the minute. Same with here, wouldn't take long to get it in the right form, but it's not quite. And this last one has got a y squared, which we cannot have. Okay, so why is this form useful? Why do I recommend knowing about it? Well, when we were talking about y equals mx plus c, what was interesting is that c was the y-intercept. So that might give you a clue that this form has got something to do with the x-intercept. Now the x-intercept of a line is just where it crosses the x-axis. And we find it by substituting y equals 0 into the equation of the line. So let's consider y equals mx minus b. And let's consider y equal to 0, because that's how we find the x-intercept. Well, when we do that, we have 0 equals m lots of x minus b, just substituted in y equals 0. Now, if m times x minus b is 0, then it has to be true that either m is 0 or x minus b is 0. That just has to be true. Because if we've got 0 as our total, and we've got we've got something times something equals 0, well, the only way to get 0 from multiplication is if one of the numbers is 0. So we know that 5 times 0 is 0. We know that 7 times 0 is 0. But there's no other way to get to 0 other than timesing by 0. So either m is 0 or x minus b is 0. Now if m is 0, we get something really boring because we just get y equals 0 as a line. And that's not really what we're talking about. We're talking about other equations of lines. So we're going to say that instead it must be x minus b equals 0. That is what has to be true. I mean, another way to get from that line to that line is just to divide both sides by m, and 0 divided by m is 0. That would also work out fine. There's two ways to logic that line. Either way, we then end up with x equal to b. So when y is 0, x is b. That means that b has to be the x-intercept of the graph. Now I hope that shows you why we use x minus b rather than x plus b. Because if it's written like this, it just means that b is automatically the x-intercept. Okay, and now you might have a hunch already what this m is, but we have to actually prove it. We have to make sure that we're correct. So to remind you, the gradient of a straight line is the amount y increases by when x increases by 1. So if I have y equals mx minus b, and I consider x plus 1, which is 1 more than x, then we're going to have y is m lots of x plus 1 minus b. If I expand those brackets out, we get y is mx plus m minus mb. And if I just focus on the first term and the last term, leave that middle term as it is, but focus on these two, I can then refactorize and get m lots of x minus b plus m. So increasing x by 1 increases y by m, which proves that m is indeed the gradient of the graph. So when we have a form like this, when we have y equals m lots of x minus b, if we have an equation written like this, then I can quickly tell you that the gradient is that m and the x-intercept is that b. So if I have y is 2 lots of x minus 3, the gradient is 2 and the x-intercept is 3. If I have y equals 2 lots of x plus 3, the gradient is 2 and the x-intercept is negative 3, because this is just meaning x minus negative 3. If we have y equals 2 lots of x minus a half, then the gradient is 2 and the x-intercept is a half. So this gives us another useful way to write a graph. I'm not saying this is better than y equals mx plus c. I'm just saying that this is another way to work with line equations. Now with y equals mx plus c, we want to know how to use the equation. We're going to do the same thing now. So if I'm given an equation, I can then draw the line. So if I'm given this equation, now at the minute this is not in the right form, this is in the form y equals mx plus c. But I can factorize, I can take out negative 2 as a factor, and I get negative 2 lots of x plus a half, because negative 2 times x is negative 2x, and negative 2 times a half is negative 1. And I can see using this form, the x-intercept must be minus a half, which is here. The gradient must be negative 2, which I can say, so if I go along 1 on the x-axis, I'm going down 2 on the y-axis to here. And then I can just draw my line through those two coordinates. So this here is the line y equals negative 2 lots of x plus a half. And of course we can check with y equals mx plus c that the gradient is still negative 2 and the y-intercept is indeed minus 1 as we expected. It's also sometimes useful to be able to go from a line to the equation form. So if I'm given a line like this, I can use this line to get it into the form y equals m lots of x minus b. So here this is the x-intercept. The x-intercept is negative 1. I can also find the gradient of this line. For every 1 across we go up 1. So the gradient is 1, which means that y is, well, 1 lot of x plus 1, which is just x plus 1. If I've got this x-intercept here, which is 1, the gradient is going to be negative 2. So y is negative 2 lots of x minus 1. The x-intercept here is 0. The gradient here, okay, so we've got a change in y of 4 over a change in x of 3, so 4 over 3. which means that y is 4/3 of x. Now notice that this was no different to y equals mx plus c, because this was just the x-intercept would happen to be the same as the y-intercept. Okay, so the key points in this video. We can write the same equation in several different forms. If our equation happens to be in the form y equals m lots of x minus b, m is the gradient and b is the x-intercept. If we have an equation in the form y equals m lots of x minus b, we can quickly draw the line, as b is the x-intercept and m is the gradient. And if we have a line, then we can find the equation of that line in the form y equals m lots of x minus b by finding the gradient and the x-intercept of the graph. I want to be clear one more time. I'm not saying that this form is better or worse than y equals mx plus c. They are both perfectly valid in different situations. It is useful to be aware of both forms and to be able to use them both.